Hello and welcome to today's lab. Within your VCL session, navigate to the course webpage on Blackboard, and along the left-hand menu, click Data, and select the NES 2008 dataset. You'll be prompted to either open or save that dataset. Click Open, and this will start your session of SPSS. Today's lab introduces bivariate analysis in SPSS. Building on your understanding of univariate analysis, including levels of measurement, as well as a basic understanding of SPSS, we can now move on to using SPSS to test hypotheses. So, for the remainder of the course, we will be measuring two variables of our observations, for instance, income and party identification, and seeing how they co-vary or move together. For example, if higher income individuals consistently vote Republican while lower income individuals vote Democrat, these two variables can be said to co-vary. Very importantly, what test we use will depend on the level of measurement for both the independent and dependent variable. A very helpful template is provided on the course webpage that helps you determine what test to use and when. The template organizes the level of measurement for the independent variable along the top and the level of measurement for the dependent variable along the left-hand column. Professor Daigle and I will make reference to this template throughout the rest of the lecture and lab videos. Your goal should be to have this filled out by the time you're doing data analysis for your final paper. So let's get started in SPSS. We've already opened the NES dataset, so let's think about a research question we may want to ask. How about, does the region in which someone resides influence party identification? After coming up with a research question, it is important to identify independent and dependent variables and to establish a research hypothesis and null hypothesis. So in this case, region is our independent variable and party identification is our dependent variable. Recall from the lecture videos that the hypothesis is a conjectural statement that specifies a directional relationship between two variables. In this case, we are seeking to understand variation in party identification by knowing the region in which someone lives. Based on the research question, we may hypothesize that those residing in the South are more likely to identify as Republican than those not residing in the South. Remember, when we hypothesize a relationship, we actually test what's called the null hypothesis, or that no relationship exists between our independent and dependent variable. A null hypothesis would be residing in the South or not has no effect on party identification. So let's use SPSS to look at these two variables. Go to Analyze, down to Descriptive Statistics, and then select Crosstabs. And you're going to want to sort your variables here. And first we're going to select our dependent variable, which is party ID 3. And we're going to place that into the rows pane here. And next we're going to choose our independent variable, which is just entitled South, and place that into the columns pane. Next, click on Cells and make sure that the observed counts is selected and the column percentages are selected. Click Continue, and then click OK. Alright, this generates what's called a crosstab, or a cross-tabulation in SPSS. Crosstabs are tables that organize observations of your independent variable and dependent variable and allow for simple comparison across categories. When building crosstabs, there are three basic rules to follow. Number one, always put the independent variable in the columns and the dependent variable in the rows. Number two, always obtain column percentages. And number three, we interpret a crosstab by comparing the cell percentages across categories of the independent variable or columns. So let's look closely at our crosstab. Remember, this is just a preliminary picture of covariation. We haven't run any tests for statistical significance. Remember that we are seeking to explain variation in party identification by introducing the variable of South or not South. So we are breaking all respondents into two categories, those residing in the South and those not residing in the South. Let's look first at the far right column, the totals column. Think of this column as simply the distribution of the dependent variable by itself. Sure enough, you can work down this column. In the first cell, there are 783 respondents in the Democrat category, 925 in the Independent category, and 590 in the Republican category. The percentages in each cell are simply the proportion of cases falling in that category. Again, this far right column should be interpreted as the distribution of the dependent variable by itself, or it is the percentage of cases in each cell that we would expect if our independent variable does not impact our dependent variable. Remember, we are interested in comparing these percentages to the percentages of each category of our independent variable. So focus your attention now on the two categories of the independent variable, or the columns. You will notice that a higher percentage of people residing in the South identifies Republicans. So 29.4% Republicans compared to an expected percentage of 25.7%. And a higher percentage of those not residing in the South identifies Democrat. Remember that our crosstab is based on a sample, which acts as an estimation of the true population parameter. A crosstab is simply a useful way to observe covariation. It is not a test to determine significance. Therefore, we only have a hunch, based on reading the crosstab, that there is a relationship here between residing in the South and party identification. In the next lab video, we'll test this relationship using chi-square for significance.
At this point, you should practice. Perhaps there are a few variables you'd like to create some crosstabs with. When you're ready, move on to the next video, which examines statistical significance and association using cross-tabulation.